Hello guys and welcome back. Today we're going to learn one of the Python library which is called Numpy. It is a linear algebra library for Python and it is so important especially for us the people who are really want to learn finance for Python and who are really interested in algo trading. In fact, we're going to use Numpy for our analysis in future. In this session, we are going to cover Numpy array. What I did, I have divided the whole Numpy things into three parts. One is Numpy arrays, one is Numpy operations, and one is Numpy indexing. And today we are going to learn Numpy arrays. So before jump into, let's talk about installation guidelines. It is important for us to understand how to install Numpy if I am facing any problem in my system when I'm running the code. So before we jump into that, let's talk about little bit installation guidelines. I always highly recommend to install Python using the Anaconda distribution just to make sure all the underlying dependencies such as linear algebra libraries like Numpy will automatically sync up when you install your Python using the Anaconda distribution. If you have not done that, no worries. You can always go back to your command prompt and run this piece of code, conda install numpy. Then you will get numpy installed in your PC. After that, you need to start with import numpy as np. So let's get started and for numpy arrays. So first we need to start with numpy arrays. So what we need to do, we have to create a list in Python. Let's say we're creating a list here as my list. Okay, and let's say my list is 1 2 3 4, and when I recall this I can get this list. My list is 1 2 3 4. Now what I'm trying to do, I'm just converting this my list into a numpy array. So what I'll do, I'll just run this np, which is numpy dot array, and then parenthesis and my list. If I run this piece of code, what I'll get, the output is array 1 2 3 4. So this list of 1 2 3 4 has now converted into a numpy array as 1 2 3 4. Okay, so next let's talk about how to create a matrix. A matrix is two-dimensional or three-dimensional. Here we can say it's a two-dimensional matrix. In finance, especially for algo trading, we use two-dimensional matrix. And here you can see how to create a two-dimensional matrix. Let's say, let me create a list, and the list name is my matrix, and this is a nested list, as you can see. In a nested list, there is 1, 2, and 3 items in this list. But then in each list, you can see another 3 items are inside that. So this is what a nested list is. So if you create this my matrix variable and if you run that, this is what you get. Now you want to change this into a 2 by 2 matrix format. So what you need to do, you just put np.array my matrix. If you run that this piece of code, then you'll get this is a 3 by 3 two-dimensional matrix. So when I'm saying 3 by 3, it means that 3 rows and 3 columns. 1 2 3 column and 1 2 3 rows. So this is a 3 by 3 two-dimensional matrix. Let's move on. So next, built-in methods. So especially there are a lot of built-in ways to generate arrays. So first one is arrange. So it means if when you want to return evenly spaced value within a given interval. If you remember, as I told in my first session in Python, there is a range function in Python. So when you put a range function, let's say from 0 to 5, you will get 0 to 5 excluding 5. So let's do this. Let's create a list here in Python. So this is my code list, then range 0, 5. So this is my minimum value, this is my maximum value. It means that I'm starting from 0, ending with 5, but excluding 5. So I'm getting this 0 and 5. Alright. So now here in Numpy, the same thing, but in arrange function. So arrange function will give you the same output but as an array. So if you put np.arrange 0, 5, then you will get the output as 0 to 5, exclude 5, but in a array. Right. Now let's say we want to add a step size. So what you have to do here, you just put np.arrange 0 and then 11, then step size 2. It means that I need a output from 0 to 11, exclude 11, but my step size is 2. The gap is 2 for each integer. So it will start from 0, then 2, then 4, then 6, then 8, and then 10, because I'm excluding 11. So but each gap is only 2. Okay, this is what when you adding a step size. Let's say you want all the odd number. Here of course you are getting all the even number because you are starting from 0 and you're giving step size is 2. Now what if you want an odd number? Very simple, you just want to start with 1. So if you say np.arrange 1, starting from 1 to 11, my step size is 2, of course you'll get all the odd numbers till 11 excluding 11. Okay, now let's move on to zeros and 1. Okay, so if you want the output as zeros, so np.zeros, then parenthesis with 5. It means that I need 5 zeros in a array. If you run this piece of code, you will get array as zeros. If you see here, 0 decimal is coming. So there are two types of output here. One is your integer, one is your float. Here, this output is float. So I just wanted to show that. So I just put a type 1 here, which is integer. If you type 1.0, this is your float. So it means that this output is a float. The same if you want to do or if you want to see this in a matrix, so you just need to pass a tuple. So np just zeros, if you just put np just zeros 5, it means that you will get 5 zeros as an output. But if you say np zeros 5 and 3 in a tuple, it means that I need a 5 by 3 matrix. So when I'm saying 5 by 3 matrix, it means that 1, 2, 3, 4, 5 is my row and 1, 2, 3 is my column. So I need a 5 by 3 matrix with zeros. So you just run this piece of code, np just zeros, 5, 3 is a tuple, then you get 5 by 3 matrix. Okay. Now move on to 1. So for 1, you just need to pass this code np.ones, the same as zeros, np.ones and 6. It means that it will give you 6, 1 is your output. So array, this is your array, numpy array, 1, and this is also a point decimal, all 6, 1, 2, 3, 4, 5, 6. Now if you want to need 3, you just put 3, 1. If you need 2, you can get 2, 1. But what if you need 5 as your output? So what you have to do, you have to multiply 5 with that. Let's say you want 3, 5. So np dot ones 3 multiplied 5, you will get 3 5. If you need 2 5, 2 5. You need 1 5, you'll get 1 5. Alright, but and then what if you want this 3 1, or you need the output 1 but into 3 by 3 matrix? So very simple, you just put the same way that we did like here as zeros. So you just need np dot ones and 3 3 pass a tuple, then you can see 3 by 3 1 matrix. Yeah, let's move on to Linspace, which means evenly spaced number over a specified interval. Remember, there is a difference between arrays and Linspace. So when I'm saying arrays with step size, as I told you, we are getting the output from start point to end point, excluding that end point, but my gap size is my step size. This is my step size. The step size is 2. But here, when I'm going to pass a Linspace, it means that the whole will be divided into 3. It means that, let's say I'm going np.linspace 0 10 and 3. It means that it will start from 0 and with 10, but it will give you 3 output. So the whole 0 to 10, it will divide into 3. If you want to change it to 4, it will get 0, 3.3, 6 and 10. It will give you 4 output. Now you want to send it to 2, then we'll get 0 and 10. And if you want to say, let's say 6, then 2, 0, 2, 4, 6, 8 and 10. So this is what the difference between Linspace and arrays with step size. Okay, now let's move on to random number, which is the function is called rand. Alright, so the rand is a function that will give you a random values in a given set from a uniform distribution over 0 to 1. Okay, now if you put np.random.rand3, it means that it will give you a random number between 0 to 1. Between 0 and 1, it will give you random 3 numbers to you. This is the function of rand. If you want, you can just click here and you just shift and tab, and then you can see. Probably if you want, you can just read all these doc strings. Okay, you can also read all the doc strings here. So these are all rand function. Alright, now let's move np.random.rand and 3. It means that it will give you 3 random numbers between 0 and 1. Okay, and this is a uniform distribution. Okay, now if you want the output as a matrix, 2 by 3 matrix, so it was np.random.rand2 3. It means that there is 2 by 3 matrix between 0 and 1 random number. Okay, so 2 row and 3 column. So if you just want to 2 by 5 matrix, you can get like that, or 3 by 5 matrix, you can get like that. Okay, so now let's talk about standard normal distribution. Okay, so which function is randn. Okay, but this is not uniform, with a mean of 0 and variance with 1. Okay, so whenever if the value is close to mean, which is 0, the probability of picking up is more here. So if you put np.random.randn with 3, so it means that it will give you 3 random numbers with standard normal distribution between 1 and 0. Okay, just run this piece of code, you will get an array of this, and this. Remember, when you're saying standard normal distribution, of course you will get a minus figure here, but when I'm saying a random number between 0 to 1, you will not get any minus figure here. Of course the output is not between 0 and 1, but this is a standard normal distribution. It can go left side and you can go right side. right? Definitely the value is not between 0 to 1, but if the value is around the mean, which is 0, so the probability of coming is more here. Okay, now let's create a matrix of uh, random number which is coming from a standard number distribution. So what I'm going to do, np.random.arrayndn, I'm 5. It means that I'm creating a 4 by 5 matrix with random numbers. Yeah, so 4 row 1 2 3 4 and 5 1 2 3 4 5. You can change it to 4 by 3 and blah blah, and then you can see the output as it. Now next is random integer. So what if you want a integer as your outcome? So the function is randint. Okay, randint. So np.random.rand integer, which is 100, starting from 1 and to 100, sorry, um, excuse me, 1 to 100 and excluding 100, right? If you run this, you'll get a output is 4. Every time you run this, you'll get random different number. So um, if you want to change it, so um, you will get a different number from starting from 2 to 100 but excluding 100, like that. So every time you run it, you will get a different number. So what if you want to say you don't need one number here, you need 2 or 3 numbers? Let's say, what if you want 3 random numbers from 3 random integers from 2 to 100? So you need to put 200 and 3. So here you go, I did it here. So it's like np.random, then integer 100, and let's say as I told 3. So you will get 3 integers as output as an array between 1 to 100 but excluding 100. Okay, so now let's move to array attributes and methods. So let's create a array np.arrange 30. So when you run this and return as array, you will get starting from 0 to 30 but excluding 30, as we have already know it. So now what if I'm what if I'm creating an random array, which is np.random rand integer 1 10 and 5. So if I run this piece of code and then I recall random array, I'll get this 5 integer 1 2 3 4 5 integer between 1 to 10 excluding fan, and which is picking randomly. Okay, now every time you run this, you will get different number. Okay, but the random number is between 1 to 10 excluding 10, and there are 5 random numbers. If you can change this, of course, let's say you want 2 random numbers, so you can change that, and then you can change it, you can get 2 random numbers. Okay, but remember, it will start from 1 but to 10 but excluding 10. Okay, and so this is how the attribution methods. Now let's talk about a little bit reshape. So reshape of array is like, if you remember, our array is is 0 to 29. Okay, and which is we have mentioned here np dot arrange 30, so which means starting from 0 to 30 but excluding 30. So if we arrange this array, right, what if you want to reshape this array? So this number you can reshape by putting as array dot reshape 5 6, and the moment you put it, you will get a matrix of 5 by 6 matrix. Okay, but what if I will change this to let's say 5? then I will get an error, because the number is 0 to 30, okay, and I'm giving 5 by 5 matrix, which is cannot be possible, right? We'll get an error of 5 by 5. It cannot reshape array of size 30 into shape 5 by 5. Remember, this number is always a multiple of this, so it has to be 5 by 6 matrix. Okay, now let's talk about max, min, argmax, and argmin. So maximum will give you the maximum value of an array. Minimum will give you the minimum value of an array. Argmax will give you the index value of the maximum value of that particular array, and argmin will give you the index value of minimum value of that particular array. So let's move to maximum. So my random array is 1 2. Let me change this, because we have to get the maximum and minimum value here. So what I need to do, let's say we're getting here 0 to 10, and I need 8 numbers. Okay, um, so let's I need the maximum value of that. So this is what my array is. So I need the maximum value of this particular array. So I will random array dot max. So I will get the maximum value is 9. Okay, and the argmax will give you the index value of 9, which is 0. So if you run that, you will get 0. And now I will get the minimum value. If I run that, I will get the minimum value is 1, and the index value of min, which is argmin, this one will give you 6, which is 0 1 2 3 4 5 6. All right, so this is what all about maximum, minimum, argmax, and argmin. Alright guys, so this is a very quick overview of NumPy array and your NumPy arrays. So this is the first session of NumPy. As I told, we have divided the whole NumPy session into 3 parts. First one is NumPy arrays, which we have already covered now. And next session or next video, I'm going to cover in NumPy operation, and the third one we're going to cover NumPy indexing. Alright guys, hopefully you understand the whole things. Please comment on this video and let me know if you have any queries, and we can talk about that. Thank you, and see you in the next video, which is NumPy operation. Thank you.